Hello guys, welcome back to the YouTube channel. Thank you for joining me again on the ZX9R build. What have I been doing today? Well, what I've done today is sort out the motorcycle wiring harness in the engine bay. It's not in its final location at the moment, and I do need to extend a few things just to free up some slack on the wires. You can see there the cables going through to the dashboard. They're a little tight. However, I mean, I can loosen them up, or what I could do is build a standoff here just to hold them in that position. There is some slack on there, but it's pulling on the throttle position sensor wire a little bit, so I could extend the throttle position sensor wiring. Is it throttle position? No, it's not. Do apologise. It is the coil wires. Yeah, I could extend the coil wires a little bit and give me some slack on that cable there, but it's not pulling it tight, and it's not as if it's going to move anywhere, so that should be good for now. The three cables that you can see there that have been labelled up as and snipped. The green wire is the positive for the left indicator lamp on the dashboard. The grey is for the right indicator lamp on the dashboard, and the red and blue one there, sorry, this one here, is for the interior dashboard lights. So obviously when you put your side lights on, your dashboard lights up. Those I've tested. The way I tested that is I used the side repeater here with positive and earth on there, took the bulb out and ran some cables directly from here and the common earth, which is a black and yellow on the clocks. So from the common earth on the clocks and the positive straight into the indicator repeater socket, and then just put the left-hand indicator on the stalks, and I was able to bring the correct warning lights up on the dashboard. So those I've got to wire in. What I'm going to do, I'm going to run a cable. They've been snipped off, so I can run cables from the car wiring, the car lights, straight into here. Now what I can do is go back through my wiring diagram that I made for the strip down of the stalks on the steering column on the micra loom, tee into that, and then branch that through under the dash and into the back of the clocks on these wires here. So that it literally just goes from the stalks to this wire, and then back into the clocks. So as soon as they're on, the lights are flashing. The other thing I can do, obviously, or that I need to do, is the headlight dipped and main beam warning lights, which I couldn't find. The wiring diagram that I have that has been kindly sent to me from the ZX9R Facebook page. Thank you very much. I think it was it Graham that sent me those? Anyway, I'll put his name in the bottom there and say thank you for sending me the wiring loom, the diagram, sorry, which has helped me out today. On that diagram, it says in this loom here it should be black with blue for the headlight main beam warning light. There isn't actually a black with blue wire here. There are lots of blue with red, and there's lots of black with red. In fact, there's two different blacks with reds, and there's loads of plain blues and there's loads of plain reds. There's no black with red, so I'm kind of struggling with that one. It might be that it's like these ones here and these ones, like they were on the micra, where they start off one colour and end up another colour on the other end. So it might be that the black with red is the colour it is at the back of the clocks, and then a little bit further down that harness it changes, because it might do actually, because I think I've poked the plugs through the hole. Sorry, I'm just thinking while I'm talking here. The plugs that have been poked through the holes are for the front indicators and the headlights and the clocks, and obviously in all the controls. So I'm assuming if there'll be a power supply coming through here, but the wire for the headlights warning to go into the clocks will be already into the cabin, so I'll have to have a look underneath the dashboard and chase that wire through. As soon as I find a black with red, I'll be able to snip that off and test it with a 9-volt battery and see if the light comes on. If it does, then I know where to wire into. So that's the way I'm going at the moment, is utilizing the motorcycle wiring from here to the clocks and the car wiring from the controls to the bulbs, and then you've got a bridge in between there in order to get the warnings up on the dashboard. So that's where I am at the moment. What I've also done is tidied up the back of the engine here. So you've got the main loom running around the back of the brace here. You've got a couple of earth straps on the back of the engine block, starter motor wire, which is an earth. Is it an earth or a power? It is, yeah, it's earth from the main ignition relay here. So that's an ignition relay, goes from positive on the battery there, ignition relay, or starter relay should I say, and then that goes directly to an earth on the starter motor. I'm assuming that the starter motor simply bridges the earth coming in from the starter solenoid and then is in series with that earth cable and grounds it through itself, so that there is only the one connection on there, which is a little strange, but it seems to work. I'm going to sneeze. I do apologise. I can feel it coming. Ooh. A lot of dust in this garage. Right, so the other things I've done, or I've found out anyway, this plug here is part of the charging and ignition system. That plugs into part of the voltage regulation system. So that plugs into it, as well as... No, it doesn't. I do apologise. Again, I'm talking crap. This plugs into the stator. So this plug here comes from where I've got the missing cover. There's a stator that sits in here, and that then plugs into here. And then these yellow cables come out. I'm going to sneeze again. God, something's got right up my nose. Anyway, so yeah, those yellow cables come through to here, which then plug into a voltage regulator, which I have got coming on the way. I've managed to sell some stuff on eBay, which has given me a lovely PayPal balance, which I can now spend on parts for this build, which is always a bonus, then I can keep it running. So yeah, these are the wires that go into the voltage regulator. This is the reason I couldn't get any lights up on the dashboard before, or any the starter kicking over or anything when I put the battery on before, is because the voltage regulator and the stator, they close the circuit. So they close the part of the ignition circuit that prevents the engine from spinning over if it's not connected properly. This is the fuel pump relay for the motorbike. I've taped it up for the minute. I don't think I'm going to use it because I've got that standalone fuel pump wiring already wired in. What I might do is change that in-tank fuel pump and run a normal inline facet low PSI pump for the carburetors, because obviously you can't run 40 PSI of fuel through a carburetor. You have to run it at about between 4 and 8 PSI. So like I said, I'm going to run a swirl pot anyway, but what I don't want to do is pump 40 PSI of fuel into a swirl pot and then only pump 6 PSI out of it, because you're going to end up with needing two regulators blowing a pump up. The 6 PSI pump will have too much pressure behind it, and you'll just blow it to pieces. And also you may overflow your swirl pot and pee fuel all over the back of your car, which isn't ideal. So what you want is a low power lift pump into the swirl pot, and then the higher pressure fuel pump pumping fuel to the carburetors. And the only way I can see you doing that correctly is to have two very low pressure pumps, one as a lift and one as a one as a lift and one as a pressure pump. The other thing I've got to work out on here is what all these pipes and connections do. I know some of them go into the airbox. There's a really lovely carbon fibre airbox with a lovely, a race pipe across filter system and everything, exactly for this set of carburetors on eBay at the moment, and on Facebook actually. And it's typical, isn't it? Everything comes up when you can't afford it, but it's it would suit this perfectly, and it's a low profile one as well, and it would fit directly under this bonnet. It just it comes up over here and then has an inlet with a pipe that comes down here, so it would be perfect. But sod's law. On this side here, what I've got is some connections for the fan controls. One of them is a temperature sensor, or temperature switch, so to say. The other one is a temperature sensor, and then you've got the actual fan. Is it one's a fan switch and one's a... Yeah, we've got a fan switch and fan wires. So this plugs into the fan on the radiator, and this plugs into the switch on the block, or on the radiator itself, or on a coolant pipe, or wherever you want to put it. Again, those ones I can extend and move around. This is the... did I put fan switch on that one? Didn't I? I don't think this one is fan switch. I've got three that, according to the wiring loom, are to do with the fans and the temperature. So I think one's a temperature sensor, one's a temperature switch, and the other one's a fan, which makes sense. You've then got speed sensor here, which normally goes in the cover that over the front sprocket in the center there, and it takes the speed of the motorcycle for the clocks off the front sprocket. Now, obviously, changing the gearing and the size of the wheels, that ratio, that speed sensor will be completely off. And I'm not going to be running a cover, and it actually bolts to the cover, so that's not going to work. However, I think it is just a reluctance sensor, so it may work being pointed at the main sprocket, and then I'll have to calibrate it to work. Failing that, I can just cut it off and use a GPS speedo stat in front of the clocks, but I would like to get it to work if possible. Moving on this way, I've just made an aluminium plate here, bolted through the old engine mount and down through into the chassis there, that was in a previous hole, and it's got the fuse box, which is just a little fuse box in there. Can't quite get that off at the minute, but that's a fuse box in there for the motorcycle fuses. And this one here, I think, is the CDI for the coils, for the ignition coils. So this will be the sort of engine control for the coils. I'm not sure if it picks it up on a cam or crank sensor. I can't see anywhere where there is a cam or a crank sensor. We've got oil pressure here. That's an oil pressure sensor there. I followed the wires around, and that is oil pressure. You've then got coil packs up here. There's no distributor or anything. It is on coils. You've then got your carburetors, so there's no fuel injection. And I can't for the life of me find a cam or a crank angle sensor. I'll have to have another deep dive into the back of the engine, because there was a loom obviously fitted, or partial loom fitted to the engine itself. So yeah, mystery. Anyway, so yeah, I've got these the two here bolted to this plate. There's some room on either side here to put some standoffs on to mount the car fuse box and the voltage regulator when it comes in. These will there'll be like a sandwich between the two, so that you can get double-deckered electronics on there. These don't need to be looked at. The fuse box might need to, but again, there's only 1 or 2 fuses in there, and you should be able to get to it from that side anyway. So, and I can put it across here so you can get it up. Anyway, I'm still working that out. So this will come across here. This battery cable will connect into this battery cable up here, which runs around there. There's plenty of slack on that, so in fact it might run into that and go across the main ignition fuse, just for a bit more safety. And then this this power cable runs into the safety switch inside, into the ignition cutoff switch inside, which then runs to the battery. Like I said, I'm removing the battery and moving it to a little bit further front and fitting a motorcycle battery anyway. So the cable that I made, this one here, the ignition switch cable for the motorcycle, again, that one may need to be deleted at some point, and the ignition switch for the motorcycle wired into the main cutoff. But for security and insurance reasons and stuff like that, it does need to be on a separate key so you can turn the engine off and then secure the vehicle. So for the moment, that's staying as it is. The other thing I've got to look at is vacuum lines, which I think is this one here. There's a line that goes around the back there and over to the front. I think that's... No, that's not. That's a breather. Oh, that's for the emissions breather system. There is a vacuum line somewhere. I may have it in my hand. Have I got it in? Is it this one? There's a fuel. These are fuel, aren't they? That's fuel there, and there's fuel here as well. I think that'll be feed and return. This one, what I actually did, I started making a braided hose for this line and this line here. I'm going to replace the fuel filter with a clear inline one so I can see what's going on. But this line here, I started making braided hoses, and I've got the braided hose here and all the connectors and everything. What I couldn't do, they're not actually very good hoses here. Undo that. So yeah, what you do is you cut the end off. You try and tape the braided hoses as tight as they can so they don't splay out. You shove that on the end over the braided line, over the braid, and then it's left-hand thread, so it screws onto the braid and holds onto the braid, and you then screw this into that bit there. And what it's supposed to do, it's supposed to force itself inside the rubber hose and then clamp the braided line to the inside of here, which is left-hand thread. Then that just screws in the end, and you've got a fuel line, or a braided fuel line. The issue I was having is when I was tightening the outside up here, or sorry, tightening the inner into it, it was pushing the braided line off the end. And I think if you have a look in there, the threads, or the left-hand threads on the inside of there, are pretty much useless. It's not gripping the braided line properly, and obviously every time you do it, you knacker the end of the braided hose, so you have to cut it off, and it's just getting shorter and shorter and shorter to the point where if I make it any shorter, it's not going to reach, and I need a feed and a return line making in braided line. I think it's -4. Might be -4 or -6. I think it's -4 braided line with the push-on fitments on the end to go onto the original fuel hoses there. Obviously, the longer they are, the more of this original hose I can take back and get rid of. But yeah, like I say, I started doing that earlier, and I was pushing so hard on the hoses that I've injured the tendons in my left arm, which is going to hurt for a few days. But never mind, it's all part of the fun. So that's where I am at the moment. Yeah, wiring. It will get tidied up again. What I'm gonna de-loom all of this, or tape it, untape it, cut it out and everything. Once everything's plugged in and once I've confirmed everything's working, it's all going to get cut back to bare wires, and then I'm going to do what I did inside. I'm going to bunch it up and relace it, or lacing cord the loom, so that it's nice and tidy, and then I'm going to run it along this brace and across here, well, probably down this mount and up across there, so it's nice and tidy. It keeps everything out of the way. And it's not going to vibrate or rub against anything. That's pretty much where I am with this. I have had a few people asking questions, which is brilliant. Thank you very much for asking the questions. I shall endeavour to answer them either on Instagram or Facebook, or wherever it is you want to ask me the questions, or here on YouTube, in fact. People are saying, how do I get drive from the engine to the wheels in a front-wheel drive setup like this? Well, it's exactly the same way as you would do it in a rear-wheel drive setup with the engine in the back, and the same way you do it on a motorcycle. The only difference is that the chain sprocket that normally bolts to the rear wheel is bolted to a differential. Now, if you think of a differential as the rear wheel of the bike, where the crown wheel sits on a differential, you unbolt that and bolt the chain wheel on the back, like you would on a back wheel, sorry, of a motorbike. You bolt the chain wheel onto the bolt pattern for the crown wheel for the diff. Now, it's not going to be the same size pattern or anything like that. You may need to machine a spacer or an adapter or drill new holes in the sprocket. Now, if you think of a differential as the rear wheel of the bike, where the crown wheel sits on a differential, you unbolt that and bolt the chain wheel on the back, like you would on a back wheel, sorry, of a motorbike. You bolt the chain wheel onto the bolt pattern for the crown wheel for the diff. Now, it's not going to be the same size pattern or anything like that. You may need to machine a spacer or an adapter or drill new holes in the sprocket if you've got a solid sprocket, which is probably the best way of doing it, is to get a solid sprocket and drill in the correct holes out of it to get it to fit. I'm probably going to end up going with a spacer or an adapter, should I say, and then running it through a differential. Now, there's different thought processes behind which differential to use and which vehicles. In a rear-wheel drive application, you can use anything. You could use a solid axle with a chain sprocket just welded to the axle like they do in a go-kart. Obviously, they use a keyway and a Woodruff key in a go-kart, but same principle. You just have a solid axle joining the back wheels together, being driven by a chain. No problem with that in a rear-wheel drive car. If you want to go around corners, you just blip the throttle and spin both wheels. You can run a differential, an open differential, like you would get in most family cars, most front-wheel drive cars, where the wheel that loses grip will send, or the engine will send the power to the wheel that has the least grip and will just spin the wheel. That's okay in a rear-wheel drive car, but it's not very quick. If you are going around a corner and you lift the inside rear wheel, you want the power that is supposed to be getting sent to both rear wheels being sent to the one that's still on the floor and not to the one that's in the air. So there are then limited slip differentials. How do you go with limited slip differentials, and which one do you go for? Well, you've got viscous coupling limited slip differentials, like you get in Mazda MX-5s, Mazda RX-8s. A lot of Japanese vehicles have viscous limited slip differentials. Some of them have viscous center differentials as well for four-wheel drive applications. But a viscous differential, basically it's a lot of plates with a load of holes inside the diff. One lot of plates is connected to the left wheel, one lot of plates is connected to the right wheel, and when the wheel with least grip spins, you have a lot of very thick, very viscous oil inside the differential, and what happens is these discs are trying to spin against each other through this oil, and at certain speeds it can't do it. Very slow speeds, yeah, like you're coming out of a junction, yes, they'll slip past each other because they're not doing too much load, there's not too much load going through them, and there's not a lot of work. The harder they're used, the harder it gets for the discs to slip inside the viscous fluid. So that's where you get the limited slip from. There's automatic torque biasing or torsion differentials, which use a set of worm gears which connects the left wheel to the right wheel. They are independently driven. However, if one wheel slips, the excess speed on that side of the axle actually drives the wheel with grip faster, rather than spinning all the power away on the wheel without grip. So the less grip you have on one wheel, the harder it will try and turn the opposite wheel. Really complicated to try and draw a diagram of a torsion differential. But once you see one working, you'll kind of understand how they either work. Well, I hope you'd understand how they work. Torsen diffs are available for most vehicles, rear-wheel drive Japanese again. S2000, I do believe, came with a torsen differential, as did the Mark 1 MX-5. I'm going to go with what's the name of the manufacturer? I keep thinking Toshiba. It's not Toshiba. It's another Japanese manufacturer beginning with a T or an H, I think it is, that manufactures the torsion diff for the Mark 1 MX-5. You've then got plate or friction differentials, limited slip diffs, which operate on a set of, a bit like a viscous differential, but instead of having viscous fluid, they're in contact with each other, a bit like clutch plates. These clutch packs or clutch plates are clamped against each other with a set of springs and a set of between the two halves of the differential casing. And what happens is, much like the viscous differential, the more torque that is applied through the differential, the more it slips. So while a viscous diff, the faster the slip of the wheel, the more difficult it becomes for it to slip. A plated differential is the opposite way around. So at low speeds and low input torque, it's locked up, and at high speeds and high input torque, it slips. So it's a plate differential. You can have lots and lots of plates in there, so it's very difficult to slip it. But you really want it the opposite way around. You want it to be open in certain circumstances, and then locked when you are putting your foot on the throttle and you're applying more torque. There are other differentials, other limited slip diffs. There's a wave track differential, which I've no idea how that works. I'd have to look that up. But they are supposed to have the best of both worlds, have the best of a plated diff with the best of a viscous diff without the complexity of a torsen diff. So no idea how they work. But again, they're quite expensive, and they're not really used in any OEM applications. They are an aftermarket only thing. What am I going to go for? Well, to answer that question, I've got to look at cost, availability, usability in a front-wheel drive application, which definitely can't be used. You can't use a solid axle in a front wheel drive application because of the fact that each one of the front wheels is independently sprung, and each one of the front wheels turns at a different angle, and they turn. So you need constant velocity joints at both ends of the axles, which requires a joint in the middle. If you have a joint in the middle and a solid axle on a front wheel drive car, it will understeer everywhere. There's no way you will be able to turn a front-wheel drive vehicle with Ackerman steering and a solidly driven axle or a welded diff. Those that do it on grass track vehicles and such rely on the fact that the inside wheel will be spinning anyway because it's on a loose surface. If you're on a track car, grippy tyres, and you run a solid front axle or front-wheel drive vehicle with a welded diff, unless you're on a drag vehicle, if you're on a track car, it will handle like a pig. You need that little bit of slip in order to allow the wheels to operate correctly under various different steering angles. I am probably going to go for a Honda S2000 torsion limited slip diff, or torsion, sorry, not torsion. Torsion limited slip diff, and the reason for that is there's plenty of aftermarket support for the diff, for the S2000, and lots of different differentials available, but they are very, very cheap. For some reason, the S2000 differential is a cheap differential. No idea why. The other major issue is, though, that on these differentials that are going in this car, they have to have a casing built for them in order to contain the oil, because normally a differential is fitted inside a case, a differential case, or a gearbox, which is full of oil, which is what lubricates the diff itself, and sometimes obviously contains the fluid for fluid coupling viscous diffs. Now, on front-wheel drive applications with a chain, because the crown wheel is taken off and the chain ring is bolted where the crown wheel should be, you cannot fit a case around it, so you have to make one. What it does, it is a sleeve that slips over the outside of the differential with a hole in the end for the drive shafts to be, or the axles, sorry, to be, no, drive shaft, I am right, the drive shaft to go through. So this shaft here for the right and the driver's side drive shaft, and the one on this side on the end of the CVs, they slot into the diff through one side goes into the normal differential side, and the other side slots in through this cup shape item, that's sleeve, if you like, that goes over the diff. You have a pressure relief valve and a couple of oiling ports on there to fill it with oil or grease, or whatever you're going to fill it with, depending on the diff. And that's pretty much it. You put bearing carriers on either side that can bolt onto a frame, slip your CV joints in, and make some drive shafts, and off you go. Put the chain on, tension the chain, and that's it. So I think I'm going to go with an S2000 differential. CV joints are readily available. All Honda stuff is pretty cheap anyway. Even the aftermarket stuff is pretty cheap. And I'm probably going to go that way and see how a front-wheel drive torsion differential operates with motorcycle engine on. The other question I've been asked, or a couple of other questions actually, but the main question I've been asked today was, why did you go for motorcycle engine in this vehicle? Well, the vehicle itself, K11 1994, 1 litre base spec 3-door tin top micra. It's the lightest of the micras available, lightest of the K11s, what they call poverty spec. It's the same sort of shell you would look for in motorsport applications, not this one specifically, but if you were buying a shell from Nissan, that you would have this spec of shell. No rust, because micras rust at the sunroof, and this doesn't have one, and it's a stiffer shell than the 5-door. and it doesn't have all the extra bolt-on bits of the other models with power steering and electric windows and all that kind of crap. No air conditioning to worry about, manual steering rack down there. So it's base spec, lightest of this shape of micra. Now, I was going to turn it into a replica of the Maxi kit car. I am still going to turn it into a replica of the Maxi kit car in looks department and obviously suspension and everything department, but the engine in that car is around 160 to 180 horsepower. There's various different reports from people that have rebuilt the engine with modern technology and got a little bit more horsepower out of it, but the original engines were about 160 horsepower. To get 160 horsepower of a Nissan Micra engine, the 1.3, it's not impossible, but it is very, very difficult. Nismo and Nissan Motorsport Europe, in two separate places in the world, one in Japan and one in Britain, tried to get reliable 150 horsepower plus from the 1.3 litre Micra engine with thousands and thousands of pounds in development and specialist equipment and forged internals and special cams and everything, and they're just not reliable. They're very expensive, not reliable, and it's only 150 horsepower. The 1.4 litre engine, which I have behind there, they're a little bit easier to get a bit more power out of, but they're even less reliable, mainly because of the pistons having a thinner ringland, so what's the word I'm looking for? Piston crown. So from the top of the piston pin, the gudgeon pin, to the top of the piston is smaller on the CGA3, the 1.4, and the cylinder walls are thinner as well. So things like forced induction on the CGA3 is, unless you are fully forged or running ductile iron sleeves, it can be touch and go. There have been a few successful versions, but the ones that are successful, again, have been high budget builds. I think one was James T, ran 200 horsepower, I think just over 200 horsepower, and his was fully forged with full standalone ECU and lots of other bits and pieces. Then there's Mr. Chris, or Sir Chris, should I say, his name on the forum, who purchased a vehicle that had upwards of 30 grand spent on it in development and parts. It basically had full WRC spec Escort Cosworth electronics on it, including sensors for pretty much everything you can think of. Again, fully forged internals, custom cams, and electric water pump, and just every. I know electric water pump's not massive, but on a Micra, it's not really something you do. It had custom wiring harness and a fuel cell and loads and loads of stuff done to it, and that one's about I think it was 260 horsepower. That was last dynoed at, but it's capable of more. But you're pushing the envelope of what's reasonably reliable with the 1.3 and 1.4 litre engines. Naturally aspirated is the way I want to go for throttle response, and for heat management. I had a turbo in here before, and it just kept getting hotter and hotter and hotter, and it's fun. But again, on an engine that's not designed for boost, you're looking at months of use rather than years before they go bang. So I decided, what's the best way of making a car powerful, fast, lightweight, with sequential gearbox, and for cheap? And the only way of achieving that is to swap a motorcycle engine into it. So what you have here is the 2000, well, you all know now, 2001 900cc Kawasaki ZX9R E1 engine, which is rated at 142 horsepower, This one has had a jet kit fitted to it, to the carburetors, and it's going to have a different airbox and everything on it, and a longer exhaust. So the guy that owned the engine before it was taken out of the bike, he said it had it dynoed at 148 horsepower as he had it, and obviously with a longer exhaust and a different airbox, I would assume this would be running at around 150-ish horsepower. With the gearing that's going to be on it, the torque at the engine will be multiplied at the wheels, so there's going to be no issue with acceleration as far as torque is concerned in gear. Obviously, you can just rev the nuts off it and drop the clutch and have it accelerate as quick as you like, but in-gear acceleration without using the clutch will be absolutely fine. The original engine that was in this car is a 1 litre, which had 55 horsepower and about 40 foot-pounds of torque. It was ridiculously small, and they do motorway speeds perfectly fine. Was it 40 foot-pounds of torque or 60 foot-pounds? I think it had more torque than it did horsepower, but not very much horsepower, about 55 horsepower, and they managed to move a fully loaded one of these vehicles pretty nicely. So this has got, I think it's 78 foot-pounds of torque at 9,000 RPM, which is plenty. And again, like I say, with the gearing, it'll be multiplied at the wheels. So, well, guys, apologies for the abruptness of the end of the video there. I do believe that my phone battery ran out as I was filming that last night. And there was a few more things to be said about the engine that's going in the vehicle, but yeah, that can be said at a later date. So I do apologise for the abruptness of the end of the video. I'll add some clips to the end of this one with some links in the description below of the few cars that have ZX9R front-wheel drive applications, and obviously some links in there to Sir Chris's 260 horse micra and James T's 200 horse micra. I'll link in the description below. So thank you very much for watching. If you'd like to like and subscribe, it would help me greatly, and it'll keep me going on with the process. And shall see you next time. Thank you.